Smart Transport is a connected car cloud analytics application integrated into Panda. Here's the problem. Connected cars are expected to generate up to 25 gigabytes of raw sensor data into the cloud. Clearly a big data problem. So here's the general automated workflow. We have car sensor data sent into the cloud, received by Panda, and streamed up to the machine learning application, who scans it and looks for possible anomalies. Thinks there's something there, and then asks the network to send up a little bit more information. Continues to look it over and confirms that indeed there is an anomaly. Of course, all of this data is stored in a database for later analysis. Now we're using a special user interface here to basically illustrate the flow of data through the system. Okay, here's our user interface. You can see up to about 25 vehicles. Now obviously this is just for demonstration purposes. In a real world deployment, we'll be dealing with a much larger data set. And you can see that the vehicles are transmitting sensor data into the cloud. On the left, we have a set of functions that considers all of the data ingested by the system from all of the vehicles. On the right, we have a set of functions focused on each individual vehicle, both for anomalies and sensor data. All right, since it does know where all the vehicles are out there in the network, it can zoom in on one and get various parameters, ID, location, name, so on and so forth. So as you can see, we can click on it, hover on it, and instantaneously identify who that vehicle is, where it is, so on and so forth. All right, so the system ingests raw sensor data, and that's what it needs to examine if it is to discover or detect any anomalies. So in terms of raw sensor data, we click on a specific vehicle, and then you can see that there are several sensors that are displayed on the right here. So we've got vehicle speed, fuel level. In actual deployments, individual vehicles will generate hundreds of sensors or activate hundreds of sensors, all of which will be sending their data up into the cloud. So here's a number of them, clearly a small subset of all of the sensors that a vehicle can transmit up into the cloud. Of course, Smart Transport receives all of them. These are just several that we've chosen to illustrate. And as you can see, the system gathers these and displays them in real time. And that's what's needed for the machine learning application. It's going to look at that data in real time to discover or to figure out if indeed there is an anomaly for that specific vehicle. All right, so how does Smart Transport handle live anomalies? Well, first of all, it will ingest the data sent up into Panda, into the cloud, look it over for possible anomalies. If it sees something, it will then ask the Smart Transport controller, hey, go out there and give me some additional sensor data. So this would be a policy. Send more data would be one policy. Machine learning looks it over, confirms it, generates some root causes, and off we go. So the vehicle here is turned red. That means that the system has identified and declared an anomaly. So on the right, we get a little bit more information about what that anomaly is. In this case, the engine temperature has exceeded a certain limit. We get a graphical representation of the sensor that was used to identify that anomaly. The system will then undertake some actions to repair the anomaly. That might be notifications to a dealership, to a partner of the automaker. Any number of different actions can be initiated after an anomaly is detected. Another example of a live anomaly detected by the system. A number of these sensors may be activated by default by the automaker, by the auto manufacturer. And I think that'll be the case as we move forward in time and more cars become connected to the cloud. Again, the cloud is a place that the automaker can use to collect, gather, analyze, store in a database, or in this case, examine in real time. System will also take or suggest recommended actions that will help repair, if you will, the anomaly, and that involves deciding what follow-up actions it should be taken. Here's a nice function. It gives you a scrolling or running log of the handling of anomalies by Smart Transport. So rather than clicking on a specific vehicle and the live anomaly button, we can just turn this on. And again, as the system identifies and takes actions to repair or resolve an anomaly, we can see that sort of displayed up there in the rolling log. Red corresponds to anomaly declaration, yellow is repair, and green indicates that actions have been taken to again repair the anomaly. All right, Smart Transport will store both raw sensor data as well as anomaly information in a database that can be used by applications for additional analysis. So just to illustrate the fact that that data is stored in a database, we can click on a vehicle, and then over a specific period of time, we can see the tracked or recorded values of individual sensors. And while the sample set is small right here, basically the same thing will happen as the system is scaled up to real-world numbers using real-world data sets. Likely you would see applications intelligently scan this data for inputs, if you will, into insights that might impact business. Here's another one, the set of historical anomalies, and this might be something that applications would use to maybe figure out issues that portend a possible problem and then perhaps avoid a costly recall, or maybe a way of improving fuel efficiency. All right, we can pretty much use all of the information to reveal insights that impact business. So here's an example of considering all of the information. What are some interesting costs? And what the system has determined is that there can be a reduction in lost productivity over the course of 12 months due to increased poor driver awareness and perhaps education. Additional business insights or analysis, not so much focused on the individual anomalies or sensors, but sort of a roll-up and analysis of, given all of the data, what is the cost, if you will. And In this case, there is a cost to dealing with poor drivers, and that might be information that's tracked by the automaker and perhaps shared with third parties like insurance companies. We're all, in many cases, stuck in traffic or otherwise not moving. Could be due to a variety of factors: traffic, weather, maybe the car's in the shop. So anytime we can reduce unproductive driving is a good thing. Depending on the application, vehicles can be negatively impacted by too much idle time. Vehicles sitting around, not moving, engines running, fuel is being burned, not a good thing. And if we can reduce the idle time, and then that will consume less fuel and save money. So smart transport, designed to generate or to deal with the massive amounts of data coming in, need a big data analytics platform. Panda is that platform that we're using in this application. And overall, we're looking to achieve safer roads, more productive and energy efficient transport or technologies, and productivity.